This video is about vertical motion model and solving using the graphing calculator. So, yesterday, vertical motion model has three different equations. We have when we throw an object up, which is h equals negative 16t squared plus vt plus s. When we throw an object down, we have h equals negative 16t squared minus vt plus s. And when we drop an object, we have h equals negative 16t squared plus s. So as a review, remember that h equals your end height, velocity is v, and if something is going up, it's going to be positive, if something's going down, it's going to be negative. T is going to represent our time, and s is going to represent our start height. So on the calculator, before we start getting into some word problems, we need to set the window on our calculator. So to hit the window, we're going to hit the button next to y equals, and we're going to put in these numbers for our window. So x min is going to be 0, x max is going to be negative 10, x scale is going to be 1, y min is going to be negative 1, y max is going to be 15, y scale is 1, and x res is also going to be 1. We're not even going to worry about the things on the bottom. We're going to hit graph, and we can see our windows all set up. So what we do is we're going to write an equation, and then we're going to split the equation into two parts. The first part of the equation is going to go in y1, and the second part's in y2, and then we're going to find our intersection point. So first it starts like we did yesterday. We're going to write our equation. So Susie drops her phone from a window at a height of 100 feet. How long until it hits the ground? So we see the word drops, so we know this is a drop problem. The starting height of the phone was 100 feet. The ending height is the ground, which is going to be 0, and there is no velocity because it's a drop equation. So when we go to write our equation, we're going to have 0 equals negative 16t squared plus 100. So in our calculator, we are going to split that equation in half. So y1 is going to be 0, y2 is going to be negative 16x instead of t because our calculator doesn't have t. So we're going to use the button that's on a diagonal from the second key for x squared plus 100. Then we're going to hit graph. Now we see that there's a blue line and a red line if you have a colored calculator. If not, you just see two lines intersecting. To find that intersection point, we're going to hit second trace. We want to find the intersection, so we're going to hit the number 5, and then we're going to hit enter 3 times. 1, 2, 3. And our intersection is x equals 2.5, so that would mean that the phone is going to hit the ground in 2.5 seconds because x is going to represent our time in the calculator, so it would be 2.5 seconds. The next one, Harry jumps off a trampoline 5 feet tall with a velocity of 6 feet up to a mat that is 8 feet tall. Does he land on the mat? So when we look at this equation, because there is a velocity, it's going to be a throw equation. So he starts at a trampoline that is 5 feet tall. That's going to be our start height. Our end height is where he's going to end up, which is 8 feet on the taller mat. And he has a velocity that is up, which is going to be positive, of 6 feet. So when we write our equation, we have 8 equals negative 16t squared plus 6t plus 5. So again, we're going to split our equations. Y equals 8 for the first equation. The second equation, we can hit the clear button and retype negative 16x squared plus 6x plus 5. So remember that we're going to use x instead of t in our calculator, and we're going to hit graph. So it wants to know, does he land on the mat? So if we look, we see one line below, and we see that blue line above. Well, the top of the red line does not go above the blue line, which means no, he's not going to land on the mat. So does he land on the mat? No, because there is no intersection point. So let's look at one more example. Ross throws water balloons from his 50-foot high roof with an initial velocity of 7 feet. Down, how long will it take for the water balloon to hit the ground? So we see the word throw, so this is a throw equation. The start height of the water balloon is 50 feet. The end height, because it's hitting the ground, is 0. And the velocity, because we're going down, is negative, so it's going to be -7. So when we rewrite our equation, it's going to be 0 equals -16t squared minus 7t plus 50. And we want to know how long it's going to take for the water balloon to hit the ground. So we're going to go to y equals. In y1, we're going to type 0 again, because we're splitting our equation in two. And in y2, we are going to type -16x squared minus 7x plus 50. We're going to hit graph. We see an intersection point, so to find that intersection point, we're going to hit second trace, option 5, and then we're going to hit enter 3 times until it says intersection. And we see that x is 1.5625, so we are going to round that to the nearest hundredth, so 2 decimal places, so it'd be 1.56 seconds.